In this video, we'll talk about XML files. First, we'll talk about what they are and what they look like. We'll briefly talk about XSD files, or rather XML schema document files. And then we'll show how to open up an XML file from our hard drive and read through the data in the file using the .NET Framework in Visual Basic. XML stands for Extensible Markup Language, and it's very similar to HTML in its use of tags. However, where HTML contains both unstructured information and how to format that information through the use of tags, XML contains structured information but contains no tags that indicate how the data should be formatted and displayed to the user. And the reason for this is that XML has a much different purpose than HTML does. XML is an easy way to store or transfer small sets of organized data between computers or between software. Now, the need for this might not be readily apparent, but consider that there are so many different software vendors that each have their own format to save their data in, and that's sometimes referred to as proprietary data formats. Transferring data between those software programs could be eased by a common language, or rather a common way of representing data that's easily readable by both humans and computers. Now, the format is not as efficient for storing or retrieving or searching through the data as the other more proprietary formats are, but it definitely has some benefits in so much that it's an open format, it's very portable. Now, the reason we're examining XML is because there's a lot of applications for it. When we were looking at the .xsd file in the previous lesson, I said that it defines the structure of an XML file. However, what might not have been very apparent was why it was used to also define a data set. Well, the reason is because the data set is managed internally by ADO.NET as an XML document. So in this manner, it makes it really easy to allow your user to retrieve data from the database in the application. Then the user can disconnect from the network or from the internet and still be able to make changes to the data to access the data. The XML then would just be saved from memory into a file on the user's hard drive and then retrieved if there's no network connection. And then later on, once they connect back to a network, all the changes that the user made can be saved back into the original data source, into the database. Or it could be imported into another program that also knows how to speak XML, and there's really a lot of creative ways that you can use this functionality within your applications. XML is also used for syndicated RSS feeds, which we're going to make use of in the last 5 videos of this lesson series. So I wanted you to become familiar with some of the basic concepts and how to navigate through the data in an XML document, how to display it on screen, and more using Visual Basic and the .NET Framework. So now I want to take a look at a simple example of what an XML file looks like by creating one for a new application. So as you can see, I've already taken the liberty of creating a new project called Lesson 10, Simple Windows Application, and I've expanded out the default form, Form 1, and have added 7 labels, which I know I'm going to need for my project, so I can display some values that are going to be contained within an XML file that we're going to pull out. And I also have a button just in the lower right-hand corner of my form. So the first thing that I want to do is select Add New Item, and from the Add New Item dialog, I'm going to select a text file. Now I anticipate that an XML file type will be included in a future version of the Visual Basic 2005 Express Edition. But for now, we're going to have to do this ourselves. So car.xml, and we're going to click the Add button on the dialog, and we get now a new empty file called cars.xml within our main area. So the first thing I want to do is paste in an XML declaration that I've got copied to my clipboard. So an XML file has to have an XML declaration at the very top to let applications know that this indeed is an XML file, or that's at least the type of information that the application should expect to see within this file. Now the very first tag within the XML declaration is version equals 1.0, And the reason that this is needed is because the specification for XML is constantly being reviewed and updated in minor ways. And what those ways are not really important for our discussion right now. But this little bit of information is really for applications so that they can know what version of the document this XML document should conform to. Now, the second part of this is the encoding style, which defines what set of characters to expect the document to be encoded in. Again, let's not worry about that too much for now. Instead, let's just create something interesting. So I'm going to take my mouse cursor and go to the next line and begin typing car lot. And notice when I put the close bracket that Visual Basic automatically adds a closing tag, so slash car lot, very much like an HTML type syntax. Now, let me explain kind of what's going on here, what this example is going to do. I've created this little fictitious scenario of a car lot, and I'm going to create an XML document that contains the details of the cars that I have for sale. And I may want to exchange this list with other car dealers that are in my area. So the thought is that there might be that I might give another car dealer a commission on any car that he sells from my car inventory. So if he doesn't have the car that his customer is looking for, he can search a database that's populated by various car dealerships around town and see if anybody else has the car that the customer is looking for. Now, if I'm a dealer on the other side of town, the benefit to me is that I'm able to sell more cars to customers that I may not have otherwise been able to reach. So this file can be loaded into whatever software each dealership uses for performing these kinds of searches. Or perhaps this document could be crawled by a search engine that displays cars over the internet to those people who are looking for car deals online. Now I realize there's probably really better systems in place that already do this sort of thing. We just need a little bit of an example here. So for the purpose of this example, just humor me for a little bit. Okay, so first I need to create a root element, which I've done here. You can see there's the car lot tag, and then there's the close car lot tag. The closing tag is differentiated by the use of that little backslash. XML documents contain one element that encloses all the other elements. This is called the root, or the root element, or even the root node sometimes. And since we're talking about terminology, sometimes I'm going to refer to the word node, and the system.xml classes use this word as well. It's just another word for element, and you can use these interchangeably, as I'm going to do throughout the rest of this video. Okay, so what I want to do next is just place my cursor between the open and closed car lot, and I'm going to add a car element or a car node. So I'm going to create a single car element within the car lot root. These are referred to as child elements. If I create two elements, these are considered to be siblings. So here, let me do this. Okay, these are considered to be siblings. And the root node is considered to be the parent element or the parent node. So think in terms of a familial relationship when working with hierarchies of XML data. And each element can contain other sub-elements, which in turn can contain other sub-elements and so on. Now, how you structure the element hierarchy is really up to you. Now, an element can also contain data. Now, you can see here that the car element doesn't really contain anything yet, but let's do this. Let's create some more nodes here. Okay. So you can see the make element contains a value. So does the model and so does elapsed mileage. These contain values, whereas the car element contains other elements, and the car lot element contains other elements, or nodes rather. So a single XML element can contain either other elements or data, but not both. So here underneath Oldsmobile, I couldn't then start to add some more tags. That would not work. Or what you could do, there's a third option here, is create a tag that contains no other elements and doesn't contain data at all. So as you can see here, I've just created an empty price element that doesn't contain anything. Now obviously this wouldn't be very useful by itself, but elements can also have what are called attributes. And attributes are information that is encoded directly in the element definition. So for example, let's go ahead and get rid of price here. Let's go back up to car, and what we can do is create an attribute called asking price equals 2,500. And also, if I haven't made this clear already, in XML, you define the tag names, or rather the element names, and the attribute names. The tag names should describe the type of data that will be stored in the element. So this makes it the XML document what's called self-describing, and so it's easy to read by both humans and computers as well. So for the most part, this is all pretty much free form. In other words, you can do whatever you want here. However, the structure you choose should be consistent and follow some pattern. So it wouldn't make a lot of sense to have one car defined like we have it right here, and then in the same document to have another car defined this way. So instead of make, we have company. Instead of model, we have style. And instead of elapsed mileage, we're capturing the year built. There should be some consistency between the data that's captured in this case, these sibling nodes. Here, we're capturing two completely different sets of information. That just doesn't make sense. Now, there's nothing wrong with either of these, but I need to pick one structure and stick with it. And the best way to define the structure of an XML document and stick to it is through the use of an XSD file, or rather an XML schema document. This document defines the hierarchy and the structure and the data types that are used in your XML document. So then it's incumbent on your XML document to make sure it follows this definition exactly. So it's a whole other document, and it is referred to or referenced at the very top of the XML document that will actually implement it or contain the values. And this XSD document is sometimes known as like metadata. It is a file that describes another type of file. So what happens if your XML document doesn't follow this definition exactly? Well, then you could have unpredictable results. The application that depends on the XML file will probably fail. It's not looking for the values that you have placed in the XML file. So we're not going to build an XSD document for this example, and I'm not going to show you how to associate an XML document with a corresponding XSD document because it's really beyond the scope of this lesson. But just keep in mind that as you begin to use XML documents that you should really learn a little bit more about XSD and gain a better understanding and appreciation of what that does for your applications and for other applications that will depend on the data as it's being transferred through the use of an XML document. But an XSD document really enables you to enforce a certain consistency within your XML documents. And this is sometimes called being valid. A valid document follows the schema, the XSD schema, that defines the structure of how the data will be represented exactly. There's another test that makes sure that the XML document follows the rules of XML, and that is whether or not the document is considered to be well-formed. A well-formed XML document has the tags in the right spots, it's not missing any ending tags, and so on. A valid document must be well-formed, but a well-formed document doesn't necessarily have to be valid. So in this case, the latter is true. We have a well-formed document. I mean, we don't have any tags in the wrong places. However, it probably wouldn't conform to some imaginary XSD document because of the inconsistency between the different types of information being collected in the car node. So again, a lot of theory here. Let's not really worry about that too much. What I'm going to do is paste in a second car node that is consistent with our first car node. We're going to get rid of the asking price here. We don't need that. We're going to save this document, and we're going to move on from here. So now what we want to do is create an application that will open this cars.xml document and display things on the screen. Now I happen to know from working through these types of examples in the past that we're going to need to do something with our example. Let's see if we can do it right now. Okay, and what we're going to need to do is take this cars.xml file and copy it into our debug directory. This will be the easiest way for our application to find the file on our hard drive. Now, we would probably want to be a little bit more sophisticated about this in the future so that we're not just hard coding a specific location for this file. We would want to give the ability for the user to select where the location of the file is stored. But for our purposes, we just want to hard code this so that we can show some quick examples. The next thing that I'm going to need to do is to create a reference between my project and the part of the .NET framework that handles XML documents. By default, this is not part of our application, so we're going to need to make a reference to that. And the way we'll do that is we're going to go to the Project menu, select Add Reference, and then we're going to look through all the .NET assemblies till we find system.xml. This is the assembly and the namespaces that will provide the XML functionality for our application. If we don't do this and we attempt to use some of the classes within our the XML namespace, our application will say, look, we've never heard of system.xml before. It'll give you some red squiggly lines and things of that nature. So you have to create a reference to this system.xml assembly so that we can use that namespace within our application. So I'm going to click the OK button, and now we should have a reference to that. Okay, now we can get down to actually working with the XML file. The first thing that we're going to need to do is open it up. So we're going to need to find the file on the hard drive and then open it up and read the data from it. And the way that we'll do this is through the use of what's called a stream reader. Now, streams are a little bit more complex concept within the .NET framework, but basically a stream is any kind of straw that sucks information out of a cup. Okay, so if that cup is the internet, then you use a stream reader to suck information out of the internet for your personal use. And the analogy of the straw is that the data comes out in a very linear sort of way, and then you have to grab that data off and do something with it. It's in a very unformatted, raw format, and so we'll have to then take that data and apply it to a specific format, and we'll use other classes within the .NET framework to do that. So to get started, what we're going to do is open up a file using a stream reader. So let's go ahead and select paste here. And I'm going to close down the Solution Explorer, just hide it for now. So you can see, first of all, we have dimsr as new system.io.streamreader, and we're going to pass in the name of our XML file, in this case, cars.xml. Now this will be the cars.xml file that we copied into our debug directory. So we don't have to use any like C:/ or anything like that, because as long as it's in the same directory as the application's executable, then we have no problem. So that's what we're going to do in this particular case. And again, the stream reader object knows how to grab data into a stream and make it available for processing. But at this point, it's very raw, it's unformatted. So what we'll need to do is take this data in this SR object now that's been streamed out and do something with it. In this case, it's XML data, so we want to turn it from a raw, unformatted format into XML. So the way we're going to do that is through the use of an XML text reader. So I'm going to paste a little bit more code in here. So you can see here that I've created dimxr as new system.xml.xml text reader. Now I could use my import statement here in order to not have to type this every time, but I want you to see the namespaces where these objects are coming from, these classes. So we're going to use an XML text reader. We're going to pass in a reference to our stream that we created here, and we grab the data from the cars.xml file into, and this simply just takes that stream and converts it in XML. That's all. Now we can work with a true XML type format. And the next thing we're going to do is convert this into what's called an XML document. And the XML document will allow us to navigate through the nodes so it understands the relationships between the parent and the child nodes. So now that we have this car lot doc, what we can do is load in the XML. So at this point, we've just created an XML document object, and now we want to load the XR, or in other words, this XML stream that we've gained from line number 11. Let's continue on. So the first little experiment that I want to conduct is, can I see if I can just grab out all the data and just put it into that to one of the labels, the first label, label 1, that we've added to our designer surface. And the way we're going to do that is through by using our car lot doc and using a special property called inner text. So let's go ahead and paste in some more code here, and you can see here using the inner text property is going to give us just the data. It's not going to give us any of the tags, so it's all going to run together with no delimiter. Let's go ahead and save this and then run our application at this point, just to make sure that we're able to open the document, load it in, and then display in label 1 the values that are contained within our XML file. And you can see that we do that. We have 2 cars and there's no delimiter. Oldsmobile with no space between that and the Cutlass Supreme and the 50,000 miles, and a Chevrolet Camaro with 60,000 miles, okay? But we're able to grab out the text, all the inner text that are contained within the tag values of our XML file. So that's pretty cool, but that's really not very useful at this point. It just shows us that we can actually get data out of it. So what we want to do next is try to just get out individual pieces of information from this document. There's several ways to go about this, and that's really what we're going to spend the majority of the remainder of this video on. So what I can do is use my car lot document, the XML document, and just grab out the first child's inner text and just determine what that is. So let's go ahead and run it now and click this, and notice that our first child node, we get that version 1.0 encoding UTF-8. Now this is, again, our XML declaration information that applications depend on, but are not so useful for human consumption. So this is probably not what we want. So just keep in mind that the first child node will always be any of the declaration statements or any references to external XML schema documents. What we really want is the car lot nodes and the values that are contained therein. So let's go ahead and paste another example here. And here we begin to see kind of the relationship and how we can navigate through an XML document, or at least one way to accomplish it. So we start off with the car lot doc dot first child, and then we can start navigating through some relationships. As you can see here, I've used the next sibling. So whatever the first child is of our document, what's the next sibling to it? That would be the car lot nodes. And then grab out the inner text there. So let's go ahead and do that. And this is going to look very similar to what we saw in our first attempt at this, where we grab out Oldsmobile Cutlass Supreme 50,000 Chevrolet Camaro. So it's grabbing out all the values that are inside of that second node. Again, not very useful because we're just pulling out too much data. So what we'll want to do at this point is do a little bit more navigation. And what I'm going to do in order to stop this this first child, next sibling, next sibling, next sibling, we could do that, and it would be a fairly lengthy line of code if we were to continue to do that. I'm just going to grab out a reference to this next sibling object, which is, again, our car lot elements, and we're going to save that into its own object of type XML node called car lot. So in this case now, we'll just be able to do car lot dot inner text. And what do you suppose we'll see there? Well, I'm guessing that it's going to look a lot like what we did right here. It's just that we were able to get to it in a more friendly manner now that we have a carlot.enterText as opposed to the carlot document dot firstchild dot nextsibling dot entertext, which is fairly lengthy and somewhat unnecessary. So let's go ahead and run it just to validate that this is indeed what we see. So okay, by grabbing that reference off, we're grabbing the exact same data as we did in our previous little example. We just have now a carlot node that makes it easy to navigate and use just that instead of having to go kind of the longhand way about it. Okay, now we're ready to get somewhere. Let's do this. Let's paste another line of code. And here, as you can see, what we're going to do is go to the first child of our carlot and grab the inner text from just that first child. So what do you suppose we'll see in this case? Let's go ahead and run and see. You can see that we're only pulling out Oldsmobile Cutlass Supreme 50,000. So by just selecting the first child, we've been able to just get a subset of the data and navigate to that and work with that only. Great. Whoops, let's go ahead and close this down. And to kind of take this idea a little bit further, let's go ahead and paste one more line of code in here. And you can see, again, using this familial type navigation through the XML document, I'm able to go to the first child of carlot. So carlot.firstchild, so that gives us that cars node, that first car, and then define its first child. So what do you suppose that will be? Well, that'll be the make. So it'll grab out just the make from our XML document for the first car. So let's go and save this and then run it again. Hit our button, and notice that here we have in label 6, first child, the first child, carlot, Oldsmobile. So we're just able to grab out just one value from that XML document. This is ultimately what we'll probably want to do most of the time. All right. So using this parent-child sibling metaphor is just one way that we can navigate through an XML document. Now it has some benefits, but it also has some disadvantages. Sometimes it can be very tedious and problematic because the document might not be formed exactly correct. It might not be formed properly. So there might be an instance where you might not have the correct nodes where your application might expect them, and you begin to deliver data that is not expected by the end user. So for example, if the make were an optional node or it didn't require the make to be in that first position of the 3 values for each car, it could be in the last position, then you would accidentally be grabbing out some other piece of data and displaying it to the end user or processing it in some way. So this isn't always the best way to go about navigating through an XML document, but it's certainly one easy metaphor that we can understand and navigate up and down, back and forth through the XML document. But there's actually a better way to do this, and that's through the use of an XPath expression. Let me paste some code in here and then we'll talk about it. So first, let's go down here. So in this particular case, we can think of the hierarchy nodes in terms of a path, much like the folder paths that exist on your hard drive. So in our particular example, what we can do here, as I've displayed right here, is just select only those nodes that are of type carlot. So let's run our example this first time. Hit our button, and notice that we get Oldsmobile Cutlass Supreme. So we're grabbing out all the inner text from just the carlot. Now, if I were to extend this and move on to something like this, the car, now you can see that it narrowed it down to the first item, so Oldsmobile Cutlass Supreme 5000, and all I had to do was just change this. And I can do even, I think, this. Let's go here. Okay, and you can see Oldsmobile there. So awesome. We're able to grab out and use this path-like syntax in order to get specific data that we want. So if I were to modify this to item number 1 instead of item number 0, what do you suppose I would be grabbing out if I were to use the select nodes? Let's go ahead and run it and see. Okay, this time I'm selecting from the second make from the cars, from the second car, okay? And that's why we're getting the value of Chevrolet, because as you can see, it's the second make value at index of 1. Or let me go ahead and just show you another way to around this. And I'll paste in one last little chunk of code here. Okay. So in this case, I've used the select nodes to grab out car lot car. And then for the first item, I use a select single node of make and place that value into a XML node called make, and then I just do make.innerText. So let's go ahead and try that method. Okay, so make.innerText equals Oldsmobile. So you can see that there's a number of different ways to navigate through XML documents to grab values out, either using a hierarchical familial type of navigation, first, next, sibling, child, parent, things of that nature, or I can use an XPath expression, which allows me to get very specific with the values that I want to pull out from specific types of nodes within my XML document. So is this important? Absolutely. XML is everywhere nowadays. And so one of the essential skills is not only understanding XML from a theory perspective about what XML is and how to construct it and use XSD documents and things of that nature, but then also programmatically how to grab data out of XML files and use them for your own particular purposes. And there's a lot of specifications that are cropping up that will be very important for the next generation of web applications in particular. And they're almost exclusively centered around the concepts within XML. RSS being one example, and there are a number of industry-specific document formats that are being agreed upon by major corporations. So XML is a very important topic. And now you know at least 2 ways that you can go through and navigate the values within an XML document. So I hope you're enjoying this series of lessons and that you enjoyed this lesson on XML. If you're enjoying this, please visit www.learnvisualstudio.net where you can download over 450 videos just like this one on various topics regarding the .NET Framework, C#, Visual Basic, ASP.NET, and a lot more. So thank you.